In this video, we're going to look at how to show two functions are inverses, and the question is, which of the following methods would be inappropriate for showing that these two functions are in fact inverses? So, some properties of inverses. We can compare the graphs of the two functions on the same set of axes, and if they look like reflections over the line y equals x, for instance, log of x and 10 to the x, they're inverses, so that's okay. What an inverse does is it swaps the input and output. So if we had a table of values for f, then g would look exactly like the opposite. So 0, 1, 2, and 2, 5, 8. Then x and g, we know, would have a table that would look like 2, 5, 8, 0, 1, 2. So we could certainly compare tables of values. Show that f of x and g of x pass the horizontal line test. So, in fact, passing the horizontal line test only tells us that it has an inverse. It doesn't tell us what the inverse is. So it's going to be C. Finally, the last two, just talk about them. Find the inverse of f of x algebraically. If we did, we would solve for x here. So we have y equals 3x plus 2. Subtract 2 off of both sides. So we have 3x equals y minus 2. Divide both sides by 3. We have x equals y minus 2. Or putting it in this form, g of x equals x minus 2 over 3. So that checks out. And finally, composing the two. So it doesn't matter which order you compose them in, you should get back to x. So let's just do one direction. So if we did f of g of x, we're putting g of x in for x in f. So we would have 3 times x minus 2 over 3 plus 2. So the 3's would cancel. We'd have x minus 2 plus 2, which equals x. And if we did in the other order, we'd find the same. So those are 4 ways of showing or verifying that we have actual inverse functions.